The specimens have been stored at 4 degrees in a laboratory fridge. Before the analytical treatment, characteristic information such as specimen number and surface description are registered in a datasheet. For instance, for a shroud specimen, the approximate surface area is noted. A bone fragment is carefully placed in a beaker for the subsequent chemical treatment, and the analysis number of the specimen is indicated. As a first step, an alpha surface contamination detector is placed on the shroud specimen to check for surface contamination by alpha emitters such as polonium-210. The number of counts is recorded and registered in the datasheet. After, the shroud specimen is folded and introduced into a 5 ml tube. The tube is weighed and the weight is registered in the datasheet. This tube is used for spectrometry of gamma radiation emitters. The specimen information is introduced into the computer and the sample is assigned for counting. The tube, including the shroud specimen, is introduced into the well of the detector to obtain maximum detecting efficiency. After 2 days of counting time, the spectrum is evaluated for the presence of lead-210, a grandmother of polonium-210. After completion of the gamma spectrometry measurement, the specimen undergoes a chemical cleaning procedure for the polonium-210 analysis. A bone specimen is covered with a solution of 1 molar sodium hydroxide and is then heated to 60 degrees within 1 hour to saponify the remaining grease and other organic material. After 1 hour saponification, most of the rotten tissue adhering to the bone fragment has been dissolved in the sodium hydroxide. The bone specimen is taken out of the sodium hydroxide solution and is rinsed with deionized water and ethanol. To fully remove the remaining organic matter within the bone structure, the bone fragment is placed in a Teflon beaker specially designed for oxidation at high pressure and high temperature. The oxidation agent used is 10% oxygenated water. The Teflon beaker is placed in the vessel, which then is introduced in the digester. The digester is closed, the program for wet washing is started. The pressure is loaded and the sample information is registered. The temperature applied is 180 degrees with a maximum pressure of 60 bar. After cooling down, the pressure is released automatically and the sample can be removed from the digester. After the wet washing, the bone fragment is fully decontaminated from the organic matter and has a characteristic ceramic color. The residual oxygenated water is washed out using deionized water and ethanol. The trabecular bone structure remained well preserved. This allows an extensive decontamination of the bone structure surface from diagenetic interferences. After drying in a circulation air oven at 60 degrees, the bone fragment is grinded carefully in a mortar. This increases the total surface of bone material for a more complete decontamination using solubility profiling. 1 gram of bone powder is weighed into a centrifuge tube and used for the solubility profiling. Solubility profiling is a method of decontamination using the different insolubility of bone apatite and other contaminating minerals, such as, for example, calcite. The solubility profiling is carried out in an acetate buffer, which preferentially dissolves carbonate compared to the bone apatite. This allows complete removal of diagenetic contaminants, such as natural polonium and lead-210. 10 milliliters of acetate buffer are added directly into the centrifuge tube. The washing is carried out during 5 minutes ultrasonication, followed by 10 minutes centrifugation. The supertenant containing the contaminant is filtered off using a special syringe filter. After 6 repetitive washings, the residue contains only biogenic polonium and lead-210, and all diagenetic contaminants have been removed. The filtered solutions are separately analyzed for polonium-210. After adjusting the volume of each of the 6 solutions to 50 milliliters with hydrochloric acid, a 1 milliliter aliquot is taken off to later determine the calcium concentration. It is essential to measure the calcium concentration, as the results will be reported as polonium-210 per gram calcium. The now fully decontaminated bone powder is subsequently dissolved in 1 molar hydrochloric acid, of which another aliquot for calcium determination is taken. A known amount of artificial polonium-209, another isotope of polonium, is introduced into the solution. It will act as a reference on the alpha spectra. It is used as an internal reference to quantify the activity of polonium-210. Ascorbic acid, a reducing agent, is added to the solution containing the dissolved bone powder to later stimulate the deposition of polonium-210. A silver disc is mounted on a special device, which then is introduced into the solution. The solution is left under magnetic steering overnight. Due to their specific chemical properties, polonium atoms are spontaneously deposited on the silver disc. Polonium-210 is an alpha emitter and emits alpha particles with high energy. These particles can be detected using a silicium semiconductor, where information about the specimen and the polonium reference are introduced. The emission of alpha particles is recorded in form of alpha spectra with different energies for polonium-210 and polonium-209. For the measurement, the silver disc with the deposited polonium-210 and 209 is introduced into an alpha chamber of the silicium semiconductor. The disc needs to be counted for a minimum of 4 days. On the final alpha spectra, the energies of polonium-210 and the reference polonium-209 are distinctly separated and counted individually. Knowing the activity of the polonium-209 reference solution, we can determine the activity of polonium-210 in our specimen.